Alright, welcome everybody. So in this video I'll be talking about the distributive property, which is something you might have seen in a previous class, and we'll review it here. Even if not, I hope that the idea is clear from this video. So our objectives, so many parts of a high school algebra class are just extensions of arithmetic. And so I always like to take the stance that let's start by just looking at numbers first and trying to understand sort of the basic arithmetic. And from there, we can work our way up to variables and functions and all that algebra stuff. So that's what we'll be doing in this video. We'll sort of explain the distributive property first with numbers, and then we'll look at what it means with variables. But I wanted to make a quick comment here. I put up a quote from one of the greatest physicists of the 20th century, Richard Feynman. So Feynman, one of the smartest people ever, pretty much. Feynman had this really good quote about names of things. And you can see the quote here, but he says essentially you can know the name of a bird. He's using an example with birds. But if you know the name of a bird in all the languages of the world, when you're finished, you still might know absolutely nothing whatever about the bird. And so he goes on to say that he learned very early the difference between knowing the name of something and knowing something. And I think that's a really profound idea, especially because so many people who like to appear like they're really intelligent or something, they often know a lot of vocabulary and sort of how to sound like they know what they're talking about. But there's a big difference between sort of knowing the names and knowing actual ideas. And so what this has to do with the distributive property, why I put this in this video is because, a lot of times students get a misconception that like math is about like learning, you have to learn all these names like the distributive property and the commutative property and the associative property. But my objective for this video is not that you know these words, it's that you come away with the simple idea that's represented by these words. And the idea really is, we'll see, it's a pretty intuitive idea that I think, anyone can understand. So I don't care so much that you know the name, but I want to know that you can apply the idea. Okay. So let's start, as I said, with numbers. Imagine that a middle school student works out this arithmetic problem, multiply 16 by 16, and the student says, well, hey, 16 is a 10 and a 6, and so I'm going to do a 10, so I'm multiplying 2 16, so I'll do the 10 times the 10 and the 6 times the 6, and I'll add them together. 10 times 10 is 100, 6 times 6 is 36. Together they make 136. But you might be, you might have your own way of doing this arithmetic, and you might be saying, hey, wait a minute, that's not right. And I'd like you to pause for a minute and think about what's wrong with this work, right? If you pop out a calculator, you'll see the answer is 256, not 136. But I think the student has some sound ideas here. Like there's some logic to what they're saying, right? Why doesn't this work is really the question. So think about that for a minute. If you don't see right away why this is wrong, but why is it wrong? And that's what we'll address in a minute. So one of our problem-solving strategies in class is when you're not sure, try drawing a picture. And so when you multiply two numbers, there's this nice geometric picture using area. So this is called the area model of multiplication. And if, again, names aren't important, but I still told you the name anyway. So say that a room is 16 feet by 16 feet. You might ask what's the area of that room. So maybe this is a floor plan or something. I don't know why I made it blue, but maybe you have a blue room. There you go. Okay, so what's the area? So to make this easier, what we can do is we can take the student's idea, which was to make the 16 a 10 and a 6, because 10 is a nice number to work with. 10 makes things easy to work with, right? So if I chopped up the room, right, I got out my measuring tape and I measured 10 feet to here and then 6 feet down here, and I did the same thing going across the room, I would see that I cut the room into 4 pieces, right? At the top left, I have a 10 foot by 10 foot room, 10 foot by 10 foot sort of part of the room, which gives me 100 square feet in area. At the top right, I have a 6 by 10, which gives me 60 square feet. Same thing in the bottom left. And then bottom right, I have a 6 by 6 part, which gives me a 36. And it's I would say it's pretty simple to add up these pieces to get the total area of 256. And so notice that like just by breaking the 16 up into a 10 and a 6, it all of a sudden, and having this picture in mind, it all of a sudden becomes much easier to multiply 16 by 16 and produce 256. You don't have to remember that long multiplication algorithm that they teach in elementary school, which I find hard to remember. I think this picture is a lot simpler and more intuitive. Okay, so do this and not that, right? So think of the picture, when in doubt, draw a picture. And we can see now clearly what the student was missing. It's like they were able to get the top left and the bottom right pieces, but they're missing all this area in the top right and bottom left, okay? They missed the cross sections. Now, if I go ahead and replace the numbers with variables, I say make this an x by x. Well, rather, let's think of it like the length of the room is x plus 6 units, and the width of the room is also x plus 6 units, so it's a square. Then what's the area inside, right? So I've just replaced the number 10 with the variable x, but you can see that plainly nothing is going to change. And you might ask, well, why are you doing that? Well, there's a lot of situations where we'll see it's easier to understand quadratic patterns and other types of patterns, actually. Sometimes we'll be looking at sort of the dimensions, and sometimes we'll be looking at the area, and it'll help us better analyze quadratic patterns and others. So here we go. What's going to happen here? Well, the x by x part of the room has area x times x. How do you get the area from the dimensions? You multiply, right? The 6 by x up here and the 6 by x down there each have area 6 times x. Oops, going the wrong way there. And then lastly, in the bottom right, 6 by 6 is still 36. Okay. So the main idea here is that the distributive property takes the dimensions of a rectangular region, right, like the height and the width, and it produces the area. Okay. So it just expresses this relationship. There's a relationship between the dimensions of the room and the area. And I can see it through the distributive property. Now, getting to the algebra, what does it look like? Well, computing the area of this room, its dimensions are x plus 6 by x plus 6, so I'm going to multiply x plus 6 times x plus 6. That's like the length and the width of the room. And what do I get? Well, we already discussed I get these 4 pieces of area, so I'm going to add them all up. I add up all the parts of the room, and that gives me the total amount of space that the floor plan takes up. Okay. Now, often we will, mathematicians will kind of clean this up a little bit and say, if you have 6 x's and you're adding 6 more x's, you have 12 x's. So you really need to work on your relationship skills. It's just too many x partners there. Okay, I get ignore that joke. And then x times x is x raised to the second power, so x squared, because this piece is a square, right? So it's x squared. Okay, and you get this simpler form. Sometimes in the books they'll call this the standard form, and they'll call this up here the factored form. The factors being the dimensions. The standard form representing all the parts of the area. Okay. And last, I just wanted to connect this to oftentimes teachers teach this as FOIL, or the swooshy thing with these little swooshy lines. And I feel like every time I say swoosh, I should get some money from Nike. I think Nike should be paying me. But I just want you to understand that this swooshy thing, where it comes from, really, it comes from looking at this picture, understanding it geometrically. And now here's kind of the algebraic representation. It's going to do x times x is the top left part. X times 6, say, is the top right part. The 6 times x down here is, say, this bottom left. And then lastly, the 6 times the 6 is this bottom right piece. Okay, so that's all I got. In summary, the distributive property, what does it do? It relates the dimensions of a rectangular region, maybe it's chopped up, and it returns the area of each piece. If you can do it with numbers, like the original example, you can do it with variables. And then understand this swooshy foily thing. If you already learned that, I don't prefer that method because I think students then lose track of the sort of geometric intuition. But if you already knew that, make sure you can connect it to the area model. Okay, so thanks for listening.